Researchers collected the following data for an enzyme-catalyzed reaction. What is the approximate numerical value of the slope of the Lineweaver-Burke plot of these kinetic data? So first of all, what does the Lineweaver-Burke plot actually look like? Well, it looks something like this, where it's a plot of 1 over the V0, which is the dependent variable, over 1 over the substrate concentration, the independent variable. And it's going to be a plot of a line. And it's in fact a double reciprocal plot, a linear plot of the Michaelis-Menten equation. Now, what is the actual plot of this line? Well, it has to follow the y is equal to mx plus b formula, right? And it's going to be this 1 over V0 is equal to the slope, which is actually Km over the Vmax, okay? And that's going to be multiplied by 1 over S, okay? So the independent variable, plus the y-intercept, which is actually 1 over Vmax, okay? So this is in the form of y is equal to m, the slope, times x plus b. So the slope, which is actually what we're trying to figure out, is Km over Vmax. So we need to figure these two out. So what is the Vmax? Well, we see that if we increase substrate concentration this way, it actually maxes out at 199 and 200, because this is actually for the Michaelis-Menten plot, V0 versus substrate concentration. So the maximum it tends to is around 200. So Vmax, we'll say, okay, is equal to 200. And so what about the Km? Well, the Km, one of the definitions for it is it's the substrate concentration at which the V0 is equal to exactly 1/2 the Vmax. So remember that 1/2 the Vmax here is exactly 1/2 of 200, so that's 100. And so the substrate concentration at which that occurs is 10. So that's the Km. So we can just plug that in. It's going to be 10 divided by 200, okay, which is simply going to be 1 over 20, okay, which is actually 0.05. So the numerical value of the slope, which is Km over Vmax, is simply b.